Hello and welcome to Forbest Academy and welcome to our AMC 12 2021 question breakdown. This week we're going to be looking at 5 AMC 12 questions and breaking down the concepts needed to answer those questions. Today's question, we're going to be looking at polynomials with complex roots. We've been given a polynomial here, x squared minus 2x plus 2, x squared minus cx plus 4, x squared minus 4x plus 8. And we've been told it has 4 distinct roots. What is the absolute value of c? So the first thing we need to do here is we need to start to find the roots of this polynomial. So we have a quadratic here, x squared minus 2x plus 2, that we can find the roots of. We're going to use our quadratic equation for that. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to rush through this because you should know how to use these. For this first polynomial here, so first quadratic here rather, we've got a is equal to 1, b is equal to -2, and c is equal to +2. If we put this into our quadratic formula, we're going to get 2 plus or minus the square root of -4 all over 2. Now we can simplify the square root to give us 2 plus or minus 2 square root of -1 over 2. And this, of course, will cancel down to 1 plus I, or plus or minus I, where I is the square root of -1. So those are our first 2 distinct roots, 1 plus I and 1 minus I. We'll move on now to our second quadratic. We have x squared minus 4x plus 8. So for this one, we've got a still equal to 1, b is going to equal -4, and c is going to equal 8. So for this equation, in our quadratic formula, we're going to get 4 plus or minus the square root of -16 all over 2. Again, we can simplify down that square root of -16 to 4 plus or minus 4 square root of -1 over 2. And that is going to give us 2 plus or minus 2i. So now we have 4 distinct roots for this polynomial. We know, because they told us in the question, that it has exactly 4 distinct roots. So therefore we know this middle quadratic here, x squared minus cx plus 4, must repeat these roots that we've already worked out. Now to decide which roots it's repeating, we're going to look at this plus 4 at the end. Now, because we need to have a positive constant value at the end there, we're going to want to use 2 of our roots, which involve a negative I and a positive I. And the reason for this is when I get I multiplied by I, that gives me -1. So if I have negative I times by positive I, it will give me -I squared, which is essentially the negative of -1, which is +1. So if I want a positive constant, we will probably be looking for a negative I and a positive I. So therefore, we are going to use the factors x minus 1 minus I, and we're going to use the other factor of x minus 2 plus 2i. So those will be our 2 factors for our middle quadratic, and then what we need to do is we'll need to expand that to find out what that middle value there is. So to do this, we're going to do a little bit of simplification with our brackets first. I'm going to change this first one into x minus 1 plus I, and I'm going to change the second one into x minus 2 minus 2i. We can now expand these brackets. X squared minus 2x minus 2ix minus x plus 2 plus 2i plus ix minus 2i minus 2i squared. We can do a little bit of simplifying here. We've got a positive 2i here and a negative 2i here, and we've already discussed that I squared will become negative 1. Now we need to collect our terms, our x squared terms. We just have the 1x squared term. For our x terms, we've got negative 2x, negative 2ix, negative x, and plus ix. So that's going to give me negative 3x, negative ix. And our constant terms, we have plus 2, and then we have negative 2 times negative 1, which is going to give me another plus 2, which gives me plus 4. So we can see we have a matching constant term to our quadratic here. So therefore, our value of c must be 3 plus ix. Now we're asked for the absolute value of this. So for this, we're going to consider our diagram with our real numbers and our imaginary numbers. So real numbers, imaginary. And this complex number is going to have a real number of 3, an imaginary number of 1. So therefore, to work out its modulus, we need to use Pythagoras. So 3 squared plus 1 squared. 3 squared is 9, 1 squared is 1, is 10. So the modulus of c, or the modulus of 3 plus I, is going to be the square root of 10, which is our answer E in this question. Thank you very much for watching today's video. Please like and subscribe if you found it useful, and please pay attention to this video for more daily breakdowns of AMC 12 and AMC 10 questions. I look forward to seeing you tomorrow for tomorrow's question breakdown.